Greetings. Now I will go through the exemplar questions in the class 11 physics chapter 2 units and measurements. Okay. Before going through it, I will show you some general information. Okay. We define force as mass into acceleration. Mass is represented with this symbol m. Acceleration is nothing but the rate of change of the velocity. So velocity is the displacement by time, that is displacement is length, time is t. So t when comes up -1, t -1. Acceleration is the rate of change of velocity by time. Okay, so lt -1 divided by again t, so lt -2. So mass into lt -2 is the dimension of this force. Okay, so when there is a constant velocity means there is no acceleration. Work is force into displacement. So force we already found the unit, displacement length. Okay, so it is ml square t -2. Torque is nothing but the rotational work. Okay, so say this as same unit. This is linear and this is rotational displacement. Okay, or torque. Impulse is force into time. So we have ml t -2 for force and t for time. So ml t -1 is the impulse. So force we already find here. So this is the one for the impulse. Then for the momentum is mass into velocity. Okay, mass m, velocity is lt -1, we already seen. So mass into velocity. Angular momentum mass into velocity into radius. Okay, so this mass, velocity, and then the radius length. Okay, m l square t -1. Surface tension is defined as force per length. Okay, so force is the mlt -2, we already seen. This length is l. So when l comes up, it cancel out. So surface tension is m l0 t -2 or m t -2, you can say. Tension is displayed into force. Okay, so m lt -1. Okay, mlt -2. Stress is also pressure only, force by area. Okay, so force by area, this is area is l square. So when it comes up, it will become l -2, then there is a l, so l -1 here. Now one astronomical unit is the average distance between the earth and the sun. This is sun, this is earth. Earth is rotating around the sun. So one time suppose the earth is here and other time as here, you want to see, you are seeing an object here, and this is the angle. This is center of the sun to engine. This angle is half of the parallax angle. Okay, this total angle theta, this one side angle is half of the parallax angle. So this one astronomical unit is the average distance between the sun and the earth is approximately 1.496 × 10⁻11 meters. Okay, one rotation is 360 degree and 1 degree is 60 minutes. 1 minute is 60 seconds. So in that 1 second is nothing but 1 arc second. Okay, 1 arc second. Okay, that is 1 divided by 360 degree into 60 minute into 60 second. This is the 1 divided by this 1 arc second. So 1 parsecond equal to 1 divided by 1 arc second. 1 arc second. So this is equal to 3008 in 10 power 16 meter. Actually this distance from here to here 16, when this theta is 1 arc second, then this distance is 3.08 in 10 power 16 meters. Okay, this is parsec. This is parsec. Okay, when theta is 1 arc second. Angular impulse is torque into time. Torque into time. Okay, this one. Okay, the number of significant figures. Okay, in this, so the leading zeros are insignificant. Okay, you see, if the number is less than 1, the zeros on the right side of the decimal point, okay, you can go through it. This is the rule, significant rules. Based on that rule, this number of significant figures here is 4. The sum of the numbers, okay, in appropriate significance, this is for the addition rule. The after decimal point, how many digits are there? Among these 3, the minimum we have to take. Okay, after decimal point, minimum of this is 2, 1 and the 3. Okay, so 1 is the minimum. So after adding, we have to, after decimal we should have only 1 digit. 14. See, for in addition and subtraction, the final result should retain as many decimal places are there in the number with the least decimal places. Okay, so we least number of decimal places you have to take, and this is the rule. The mass and volume of the body given respectively, the density, you are going to use this formula and you are going to again apply the significant figure rule. So this is for the okay, I will show you that multiplication division rule. Okay, round with the least number of significant figures. Density is mass by volume. So you can see the rule here. This is for the this rule, multiplication and division rule you have to apply. There is also one example 15. Okay, here also there is a given example, so you can go through this example. Okay, how many digits after division, how many significant figure they are using. The number on rounding up, see here in 3 significant figure they are going to round up 1, 2, 3. After 3 this 5 is there. So when you round up, whether this before that number, whether 4 and 3, whether this even number or odd number, that rule you have to apply. Okay, so here again 15. So you have to use this rule here. When you rounding up the 5, then whether it is a even number or odd number before that digit, based on that rule you have to round up. So here, so we are rounding. This is the even number. Here we are not adding anything. This is the odd number, so we are taking. So this is the answer. The length and breadth of a rectangular sheet is given. The area of the sheet, we are multiplying the two number and we are going to find out the error in this. Okay, so here they given that example here, how they are finding up the percentage error, and they are after rounding they are arriving at this. which of the following physical quantity does not have the same dimensional formula? So I already shown you in the general. So this tension and surface tension, they don't have the same formula. Measure the two quantities along with the precision and respective measuring instruments is given. So you have to apply the error rule here. That is product of the error. So here product of the error you have to use. This is the sum of the error, then this is the product of the error also is there. Okay, so you have to use this rule. This is AB. Here also you have to use the AB and then the root. Which of the following measurement is most precise? There is a difference between the precise and the accuracy. Okay, so what is precision and what is accurate? So here this is here we have the smallest difference, okay, in this. So we are using in millimeter, that is smallest among this, so it will be more precise here. 7. So this is the difference between the precision and the accuracy, okay. The mean length is 5 centimeter. Which of the following? Here they are asking which is accurate. Accurate is nothing but more close to the original value, okay. Close to the actual value. This is original value which is more close, and this is the one more close. Now model given when expressed in CGS unit, it will be equal to the 11. CGS means centimeter gram second, okay. Total. So this is given. So we are converting meter into centimeter, and 1.9 this Newton we are going to this unit, okay. After then we are converting this into centimeter, then finally we are arriving this CGS, centimeter gram second, okay. We are substituting for the Newton the 10 power minus 10 power 5 then. If momentum, area and time are taken as the fundamental quantities, the energy as the dimensional formula, you have to apply the homogeneity rules. 12. So the energy equal to ml square T minus 2, then P mass, the area and the time they have given. So the left side dimensional formula, this is the right side dimensional formula. Then A equal to, this is given here A equal to here 1, because this power is 1. A plus 2B equal to 2, then we are finding out the other units, okay, other parameters. Page 8. So how to derive the units? Okay, here they are given one example. You can go through this, okay. Okay, 2 on the basis of the dimension, Decide which of the following relations for the displacement of the particle undergoing simple organ is not correct. They are asking which is not correct. Okay, so here actually these two having the dimensions. Okay, sine, cosine, trigonometric function should be dimensionals, but here they are having dimension, so these things are not correct. Okay, PQ are the physical quantities having different dimensions. Which of the following combinations cannot be meaningful? Because when you subtract they should have the same quantity. So here they have the different quantities, means this cannot be done. This kind of homogeneity, addition and subtraction are the same quantities only. Okay, this also can't be done. Photon is the quantum of radiation E equal to hv, where V is the frequency and h is the Planck constant. The dimension of the h are same as that of, okay, linear impulse dimension same as the linear momentum. Okay, linear impulse, linear momentum both are same. I already shown you some basic unit. Okay, angular impulse unit same as the angular momentum. Dimension of the h same as that of this is angular impulse and angular momentum, both are having same unit. The Planck's constant h and the speed of light in vacuum are taken as the two fundamental units. Which of the following in addition taken express the length, mass and time in terms of the chosen fundamental unit? You have to apply this homogeneous rule as we already done. Then after that you can use one of these three units as of the electron, mass, proton and the gravitational constant as the mass. Which of the following which of the following ratios express pressure? Force by area, energy by volume. These two are the pressure. Which of the following are not the unit of the time? So actually you know this second and year, this unit of time. The parsec I already shown you, that is for the distance measurement, long distance measurement between the stars and the earth. The light year also belongs to that only. So this 6. So here also they given this for the long distance measurements, astronomical units. Why do we have a different units for the same physical quantity? So you can see the answer. Okay, because what is differ in order of magnitude significantly in respect of the same physical quantity? For example, these intraatomic distances. Okay, you can go through this. The radius of the atom of the one Armstrong and the radius of the nucleus is this how many magnitudes higher as the volume of the atom as compared to the volume of the nucleus and the atom volume. So they given this, you can go through it. Okay, 10 power 15. Name the device used for measuring the mass of atoms and molecules. 21. mass spectrograph. Okay, mass spectrograph. Express unified atomic mass unit in kg. Okay, one atomic mass unit is this many kg. Okay, it's given here. 1/12 of the mass of the carbon 12. A function is defined this. Why it is necessary for this theta to be the dimensionless quantity? I think the power should be dimensionless. 23. F of theta is the sum of different powers, so it has to be dimensionless. So these are the dimensionless quantities, powers, trigonometric functions, these things. Okay. Why length, mass, time are chosen as the base quantities on the mechanics? Because all the other quantities can be expressed in terms of length, mass, time through simple relations. The Earth Moon distance is about the X radius. What will be the diameter approximately in degrees as seen from the Moon? Okay, so this answer Moon is in. Okay, these things clearly given in the answer. 25. Okay. Theta equal to this many radians. Diameter of the earth as seen is about so you can go through it. Okay, here R stands for the distance, D distance, R stands for the distance, D for the diameter. Okay, which of the following time measuring devices is most accurate? Okay, 26. Atomic clock is the most precise for measuring most precise time measuring device because the atomic oscillation are repeated. The precision is given 26 7. This is the atomic clock, is the most accurate. The distance of the galaxy of the order of this, calculate the order of the time taken by to reach thing. Okay, distance divided by the speed of light. Distance divided by the speed of light, you will get this much seconds. The NCERT scale of the traveling microscope, 50 division, main scale divisions. Points of the 49 main scale divisions. Vernier scale 50 division consider the 49. If each main scale division is 0.5 mm, calculate the minimum accuracy. Okay, 28. minimum accuracy, one main scale division minus one vernier scale division. So one main scale division they have given 0.5 mm. This vernier scale division also you are converting into the main scale division. Then after that this is 0.01 mm accuracy. During the total solar eclipse, the moon is entirely covers the sphere of the sun. Write the relation. So okay, this moon, sun, they are given the relations. Okay, so you can go through it. If unit of force 100 Newton, unit of length, and the unit of time, what is the unit of the mass of the system in unit? System of units, okay, 30. This my kg they are given. I will show you how they are converted. 30. Okay, mass into acceleration is given. So after that the mass is equal to 10 power 5 kg. Give the example of a physical quantity which has unit but no dimensions, a physical quantity which has neither unit nor dimension, a constant which has unit, a constant no unit. 31. So these things is the answers they are given. Calculate the length of the arc. Arc of radius they are given. Angle given, the circle radius and angle given, they are given asking for the length. 32. This is the formula they used. I will show you. 32. So 360 degrees equal to 2 pi radians. Okay, so 2 pi r, this is, so 1 degree equal to this many centimeters. Okay, so they are asking for 30 degrees. 30 degrees will be equal to this many 16.3 centimeter. Okay, calculate the solid angle subtended by the perimeter of the radius of 1 centimeter square at a point situated symmetrically at a distance of 5 centimeter from the area. Area divided by the radius square. Page 2, so the answer 33. 33, this much is coming. Book page 2. Okay, solid angle here, area of the sphere divided by the to the square of the radius, area divided by the square of the radius. Okay, radius into radius, 1 divided by 5 into 5 centimeter. The displacement of a progressive is represented, okay, where x is the distance, t is the time. Write the dimensional formula for these and these. Trigonometric analysis should be dimensionless, okay, and that is as per the book. 34. 34. Okay, so in that case it should be time minus 1, length minus 1. So this should be here time minus 1, here length minus 1. Then only the inside the argument will become dimensionless. Time for the 20 oscillation of the pendulum measured. What is the precision of the measurement? So what is the accuracy of the measurement? 35. Precision is given by the least count of the measurements. 20 oscillations this much, 1 oscillation this much. So the maximum observed error they are computed. Okay. So whichever answers are given in this, so you can go through it along with the book. A new system of unit is proposed. So the mass is alpha gauge, units of beta and the unit of time. These things are given. How much is the 5 joules measure in this new system of units? Okay, 36. Since energy is this dimension of joules, the unit will be the mass length time, so you are multiplying it. 36, 37. The volume of the liquid flowing out per second of the pipe is given the formula, where P is the pressure difference between the two ends of the pipe, and this is the coefficient of the viscosity of the liquid. Having dimensional formula, this thing, check whether this equation is dimensionally correct. 37. Dimensional part of the expression, okay, therefore they are substituting the dimensions, which is the volume upon time. Hence the formula is dimensionally correct. Right hand side. The physical quantity x is related to the 4 measurable quantities. Okay, they are given. The percentage error of the measure and the percentage error 38. So refer to the book and see whether this formula is applied correctly here. The expression given G denote energy, mass, angular momentum and the gravitational constant respectively. Show that P is the dimensionless quantity. 39. Okay, E gravitational constants. So finally we have no dimension, so B is a dimensionless. velocity of light, Planck's constant h and gravitational constant are taken as the fundamental quantity, then express mass, length and time in terms of dimension of these quantities. You have to apply this rule, homogeneous rule 40. So after applying, we are finding mass, length and the time. One also you can go through the answers. Okay. So these things you can go through the answer. The here important thing is this various unit, which are the new unit, the astronomical unit, parsec, arcsec, those things I already mentioned. So here this is important. This is to illustrate why a telescope can magnify the planets, not the stars. Okay. So you can go through the answers given in the 43. They given 1 arcsec, I already shown you 1 divided by 360, that many radians. So you can go through this. Okay, you go through the answers given in the answer thing. Then try out the problems in the book, that is solve the problems in the book. Lot of solved problems are there. So you try out these solved problems yourself. Then only you will get familiar with these various unit conversions. Okay.